So here we're going to look at an example of an improper integral, and we're going to determine if the improper integral converges or diverges. And the integral is from 1 to infinity. That's what makes this improper, of the function 1 over x dx a hyperbola. So let's take a look at what this integral represents. So let's draw a picture. It's easy to graph 1 over x. So here's the graph in the first quadrant. Since we're integrating from 1 to infinity, there's 1. And this integral represents this area below the graph of f of x equals 1 over x above the x-axis from 1 all the way to the right. If the integral converges, the area is finite. If the integral diverges, the area is infinite. So the way we handle it is we let t represent any positive number to the right of 1. And so we're going to compute the area from 1 to t and let t go to infinity. And if that limit exists, that will equal to the convergence value of the our improper integral. So the way we write this is the improper integral from 1 to infinity of 1 over x dx is equal to the limit as t approaches infinity of the proper integral from 1 to t 1 over x dx. So this is an easy integral. It's going to be natural log of x without the absolute value, since we're only dealing with positive numbers. And this is the limit as t goes to infinity, natural log of x evaluated from 1 to t. So when we plug it in, we still have the limit as t goes to infinity. And then we plug in t and 1 for x. So that's natural log of t minus natural log of 1. Of course, natural log of 1 is 0. And what we have to do is evaluate the limit as t goes to infinity of ln of t, and that, of course, is infinity. And we can then conclude the improper integral from 1 to infinity, 1 over x dx diverges. The area captured below the function 1 over x is infinite. There's a second way to do this, slightly different. So I'm going to go ahead and present it here, and then you decide whichever one is easier for you. So here, we're not going to take the limit first. We're going to take an antiderivative of 1 over x, which is ln of x, and we'll write it as 1 to infinity. The infinity part means that to evaluate it, you don't actually plug infinity for x. It means take the limit as x goes to infinity of natural log of x minus natural log of 1. And now we have the same limit as we had before. The only difference is the variable was t before, now it's x. It still goes to infinity, and the conclusion is still the same, that the improper integral from 1 to infinity of 1 over x dx diverges.